In this video, we're going to talk about 1.2 Objective 6, where we graph and analyze functions. Let's consider the graph of f of x is equal to x to the third power minus 3x to the second power plus 11. We're going to graph it in the window of -8 to 8 with an x scale of 2 and -16 to 16 with a y scale of 2. These other numbers don't matter. So that's going to look like B. Find the domain of the function. It's a polynomial, so it's going to go from -infinity to infinity. Let's determine the peaks of the function. So second calc here, maximum. We're looking for this point right up here. It's a high point, so I'm going to cut an interval out from left to right that contains it and get kind of close to it to guess. And we have function has a peak near x equals 0. And then let's determine the valleys. Second calc minimum, number 3. Again, we're going to cut out an interval that contains this. Make a guess somewhere kind of close. And that looks like 2. There's going to be a little bit of rounding error with the calculator sometimes because it's using the pixels to generate these numbers. It's not actually solving the equation. If we would solve the equation here, set x equal to 0, we would get 11. And if we would factor this using synthetic division or long division or whatever, we could find where the where x-intercepts would be. We weren't asked about that, but we can find y-intercepts by setting x equal to 0. Y-intercepts by setting x equal to 0. X-intercepts by setting the function equal to 0. That's our next question here. And we're going to have to approximate them using the calculator. So second calc 0 is an x-intercept. And that 0 is over here. You're going to see that it's going to be a irrational number, non-repeating, non-terminating decimal. If you have trouble seeing that number at all because it's kind of small, it saves it as the x value. Come back to your home screen, hit x, and you'll see it a little bigger there. So the x-intercept is -1.550. They tell you to type in ordered pairs here. And the y-intercept is 0, 11. All right. Now let's look at this graph. Math number absolute value function. Numerator is x squared minus 2. Denominator is x plus 5. Window of interest is -10 to 10 with a scale of 1, and -25 to 25 with a scale of 2.5. And that looks to me like D. The domain of the function. X is not allowed to be -5, which would make the denominator 0. But we have to answer an interval notation here. So -infinity to -5, union -5 to infinity. Now let's look for any peaks in the graph. So it's hard to see, but this piece over here goes down, comes up, goes back down, and goes back up. So there's a peak that's right here. There's going to be valleys that are over here and over here. This piece that is up here is going to always be increasing like that. This is going like that and coming towards this horizontal asymptote from below. So we're not going to have any peaks or valleys on this piece. Once this turns here, it's going to have what's called a point of inflection over here, but it's not going to have a minimum or a maximum. So we're looking for this piece here, second calc maximum. It's going to be somewhere in this area where it's rising and then falling on the other side. And that looks like -0.204. Tells us to go to the thousandths this time, which is 3 decimal places. Now we need to find these valleys, which are just to the left of that. Coming down, and then we start coming up over here. Somewhere in there, there's a valley at -1.414. Okay. There's another one over here at +1.414. And then there's one that's really hard to see over here. I missed it when I was talking to you before, but it does turn and go back up. So we're gonna have to look really close over here. But you can see it better. If you come a little bit more to the left, see how it's coming down and then starts going up again. So -9.796. So the window that they give you is not always necessarily going to be the best window, which is why there are instructions to tell you to experiment with different windows to see how the graph changes on different scales. So we might have needed to examine other parts of the graph that weren't in the window to get answers to these questions. What are the intercepts? So let's go ahead, and we're looking for x-intercepts down in this area. So let's zoom in on that area in particular. We know we're not going to get any x-intercepts from the other piece. Look at this area of interest right here for x and y intercepts. Let's cut that box out. Okay. So second calc 0. I think there's an x-intercept that is somewhere in there. That's it. Negative 1.4140. And then the other one at positive 1.4140. We've already found that point over there. And then the y-intercept was 0, and it was negative 2/5, which becomes 2/5, which is 0.4. All right. Let's go ahead and look at this next function here. Numerator is negative 3 square root of 9x squared minus 36. Get out of the square root, close the numerator, divide by, denominator is 3x plus 4. Suggested window here is negative 30 to 30. With scale of 2, negative 6 to 6, the scale of 1. And this happens sometimes that the graphs run together. It's just a printing error sometimes on my end. So I'm going to show you what the graph is supposed to look like. And there's additional behavior here that you're not seeing, that there's going to be x-intercepts, that, let's prove it to you, 9x squared minus 36 equals 0. 9x squared equals 36. X squared equals 4. X equals plus or minus 2. So we're going to be coming all the way down here and stopping, and all the way up there and stopping. I'll zoom in on that part of the graph when we get to the x-intercepts to make sure that you see it. But the there should not be any behavior close to the vertical asymptote. There's going to be a vertical asymptote at x equals negative 4/3 if that's in the domain. Let's check out what our domain is here to be sure that we know that in here we have negative 2 to 2. 4/3 we know is, I'm sorry, negative 4/3 we know is negative 1 1/3 is over here. Maybe we have that interval, maybe we don't. So let's stick in a number less than negative 2, like negative 3. It's going to give us 9 times 9 is 81. Minus 36 is a positive number, so I have this region. Let's stick in a number in the middle there, like 0. 0 minus 36 is negative. So no, this area in here does not exist. Don't worry about that vertical asymptote. To the right of 2 is going to be like 3. Again, we get 81 times 9, big number minus 36. So it's going to exist here. So my domain is going to be negative infinity to negative 2 included, union 2 to infinity. These are brackets, it's closed. And it is going to be this piece that's hard to see here, but it's this stuff with the asymptote here, and then this stuff right here with the asymptote down here. That right there that I have in blue is supposed to be the graph, which is option B. Here it's the second one, so again, sorry that it all got run together instead of stacking over and under like it was supposed to. So we know that, let's answer the x-intercepts question because we've already answered that. There's not going to be a y-intercept, but there are going to be x-intercepts. Two zero, 2 0. We talked about that. Peaks. Second calc maximum. So peak right there at x equals -3. And there is a valley. It's kind of hard to see. No valley. I was looking at the wrong picture. No valley. It's always increasing here, always decreasing there. And then it just increases, starts decreasing right here to go down to the x-intercept. So that's the one turning point that it has. X-intercept on down here, always decreasing. So only that one turning point that we're interested in, right? X increases in, as X increases in the positive direction, the values of f of x approach y equals -3. You see that right over here, y equals -3 is this horizontal asymptote. And up here, as x goes in the negative direction, y approaches +3 is that horizontal asymptote. See if I missed anything. Nope, that's everything. So see the two asymptotes here are at -3 on this side and +3 on this side. Okay. Would have been a lot better, a lot easier to do that if we had the multiple choice picture there. Let's go ahead and move on here and talk about this graph. analyze it. So consider the graph of the function f shown in the figure and answer parts A through E by referring to points A through I. Which points correspond to the roots or zeros of f? That would be A, D, and F, and I. A, D, F, and I. Which points correspond to the high points or peaks? So that's B and H. Which points correspond to the low points or valleys? That is E. As you move along the curve in the position in the positive x direction, at which point is the graph rising most rapidly? Where does it have the steepest, most positive slope? Is what they're asking there. So you see the slope is kind of like that there. You know, it's completely flat there. It's decreasing. Here's slope, but that's less positive than that slope. It's also still less positive. That's definitely zero. This is negative. So the most positive slope there is at A. As you move in the positive x direction, what point is falling most rapidly? Where's the most negative slope? Again, just use your hand or a piece of paper or a straight edge to see this, but we're only concerned with where it has negative slope. There's negative slope. There's negative slope, zero slope, positive slope. Looks like the most negative slope there is going to happen at I. Right? Let's keep going here. Make a sketch of the given pairs of functions. Be sure to draw the graphs accurately relative to each other. So y equals x cubed, y equals x to the fourth. So x cubed is going to rise to the right. X to the fourth is going to open up. They both are going to go through 0, 0. So that's C. Now we have y equals the square root of x, x to the 1/2, and y equals x to the 1/6. X to the 1/6 is going to start off higher than x to the 1/2. They're going to cross each other both at 0, 0 and at 1, 1. And then x to the 1/2 is going to overtake x to the 1/6. It's going to look like A. Consider the general quadratic function y f of x equals ax squared plus bx plus c, with a not equal to 0. Find the coordinates of the vertex in the terms of a, b, and c. You know that the x coordinate here is negative b over 2a. Let's just complete the square here. That's what they want us to do. So a x squared plus b over a x plus c, half of the middle number squared, b squared over 4a is minus b squared over 4a. This is 4a squared, so b over 2a squared is what I did to get this number here, is b squared over 2 times 2 is 4, a times a is a squared. I added a times b squared over 4a squared. So I added b squared over 4a. Since I added it into the problem, I need to subtract it from the problem over here. That makes this x minus b over 2a, quantity squared. And then plus this is c minus b squared over 4a. This is my h value of my vertex. This is my k value of my vertex. C minus b squared over 4a. Did not make a common denominator there. You can do that if you want to. That would be 4ac minus b squared over 4a if you would like to write it that way. And you might see where the 4ac in the quadratic formula comes from, the b squared minus 4ac. Okay. I'll find the conditions on A, B, and C that guarantee that the graph of f crosses the x-axis twice. So that would be inside the quadratic formula, we want b squared minus 4ac to be greater than 0. And that's it for this video. And we'll come back next time and we'll be talking about 1.2 objective 7. See you for the next video.